You must know how to solve this question. Amazon, Google, Apple, and Microsoft, they're all asking this question. We are given an array of coins that have different kinds of coins, and we have the amount. Basically, we need to come up with the various number of coins that we can make up to the amount. For example, if we have the amount 11, we can have 5 plus 5 plus 1. This is the various of coins that we can make up to 11. Another example will be if this is 10, then we have 5 plus 5, which at least 2 coins we need to take in order to make to 10. If there's no way we can make up to the number, for example, if we are given coins 2 and the amount 3, we need to return -1. There are multiple ways to solve this question. Apparently, we can use the brute force to have all the combination and then we select the various. But we have an explanation time complexity, which is not we want. Next, I'm going to talk about dynamic programming. We have two different approaches. One is top down and one is bottom up. The complexity is S times N. S means the amount and then N means the count of calculation. I'll talk about the details later. The reason this is called DP top down is that initially we have the number. Each time we subtract the number with the coins we have. If we are reaching 0, that means we have a valid path. For example, if we are following this path here, we can have initially 5 and then 2 and then 1. That sums to 8. Now let's pick number 7. How do we know the various number of coins that we can make to 7? Well, we can look down. Apparently, we can select the mean from DP6, 5 and 2. The various coins we can make to 6, it's 1 plus 5, so this is 2. And this is 1 and this is 1. So the various coin that we can make to 7 is actually the mean of those coins plus 1. So this is 2. Please do keep that in mind that the negative number means this is an invalid path. And also you can actually catch the result, so you only need to calculate by once. The time complexity is all S times M because S means the amount, which is the height of the tree. And then N means the width of the tree. This is the Python code. First, I declare a temporary result to cache. And then this is the DP function. If the current N is already in the cache, then we can just return it without a further calculation. We have two different base cases. If N is equal to 0, that means you have a valid path like this. If N is less than 0, we need to return -1. That means we have an invalid path like this. Just like I demoed before, at each stage, we need to get the various coins that need to made up to this number. So this is the for loop. And every time we check if it is a valid path. There is another approach called DP bottom up. Instead of top down, for bottom up, we need to build from 0 until we reach to 8. The DP function means we return the various number made up to the coin. For example, for 1, we can just simply select 1. For 2, we have 2. But for 3, we have 1 plus 2, so we need 2 coins to make up to 3. Now, how do we reach out to the target 8? From the coins we have, we know the final step to reach out to 8 is 8 minus 1, which is 7, 8 minus 2, which is 6, and 8 minus 5, which is 3. So we can only select from those 3 DP, and we need to select the minimum. There is a +1 here. That means based on the DP we have, we need another extra step to reach out to 8. This is the Python code. First, we initialize a DP array with the maximum integer. This is easy for us to compare with the various number later. We have a second for loop for coins. That means we need to go back. Every time we have the I, we subtract with the coin we have, and then we accumulate to the current DP. So this is main function. It's equivalent to what we have. If you like this channel, please click like and subscribe. Thank you.